Good morning and welcome to my presentation. This is Saiful Bari, PhD candidate at the University of New England, Australia, joined with Commonwealth Scientific and Industrial Research Organization in Armidale, Australia. Now I am going to talk about part of my PhD research with parents laying hens, where we tested how rearing enrichments, outdoor ranging, and implemented stressor impacted hen adaptation and welfare. Rearing enrichments might contribute to better adaptation of hens as they move from indoor rearing to a free-range housing system. The improved adaptability may contribute to better welfare. Individual variation in outdoor ranging might also be associated with differences in hen welfare. In this context, we evaluated the effect of rearing enrichments on hen welfare and adaptability to an imposed stressor along with the association of outdoor ranging with hen welfare. We reared 1,386 highline brown Deor 6 indoors up to 16 weeks, providing 3 enrichment treatments, including a control group with a standard litter housing without any added materials, a novelty group where we provided several novel objects such as box, toys, brushes, and changed them at weekly intervals, and a structural group where we placed edge-shaped parsing structures for enhancing navigation. At 16 weeks, the birds were moved to a free-range housing facility and provided outdoor access from 25 weeks of age, and their movements were tracked by adding microchips on leg bands and using a radio frequency identification system. At 44 weeks of age, an environmental stressor was applied by reducing the range area up to 80%. Range use data of before and after stressing were assessed to evaluate the effect of the stressor on ranging behavior. Egg albumin samples were taken from all pens before stressing as baseline, first week of stress as immediate, and second week of stress as prolonged samples. For measuring the egg quality parameters, 270 eggs from each time of baseline, immediate, and prolonged stress were collected and analyzed. Individual hen welfare assessments were performed at 25, 33, 43, 56, and 64 weeks of age and correlated with their outdoor ranging time prior to these assessment dates. There was an interaction between rearing enrichments and hen age for the live weight of hens, with more consistent live weight in the enriched hens. There was also an interaction between rearing enrichments and hen age for the number of compounds in hens, with fewer compounds in the enriched hens. Number of compounds are likely related with pecking behavior. Enriched hens might have improved social interactions with reduced pecking. There was an interaction between rearing enrichments and hen age for the plumage coverage score in hens, with more plumage coverage in the enriched hens. Enriched hens might be less stressed and thus show less feather pecking behavior. There was also an interaction between rearing enrichments and hen age for the toenail length of hens, with shorter toenails observed in structural group of hens. Toenail length might be associated with walking and scratching during ranging and foraging, and the structural hens did show the most ranging across the trial. The ranging time per day was decreased due to stressor applied in all of the rearing and treatment groups, but the number of visits was increased, followed by stressing, with a significantly smaller increase in visits observed in the structural group of hens. The structural enrichment might have contributed to the spatial navigation of adult hens, which then minimized the stressor effect on ranging through improved adaptation to the new environment. The rearing enrichments and stressor treatment showed a significant interaction with the egg albumin corticosteroid concentration of free-range hens, with a significant decrease in the corticosteroid level in structural hens, both in immediate and prolonged stress. This indicated that the structural hens were less stressed. The structural hens may have been more adaptable to environmental changes, thus showed a lower physiological stress response. The stressor affected all of the egg quality parameters except eggshell thickness, but there was no difference in the parameters values across different rearing treatments. This indicates that the stressor affected the egg quality, but rearing enrichments did not minimize these effects. There might have more impacts of feed intake on egg quality, and stressor might have reduced feed intake of the hens from all rearing enrichments. In a nutshell, rearing enrichments affected hen welfare across the flock cycle. Outdoor ranging was associated with free-range hen welfare, and egg quality parameters were impacted by stressor, but rearing enrichments did not minimize these effects. Overall, rearing enrichments along with optimum ranging might be recommended for positive effects on hen welfare. It is our privilege to acknowledge Poultry Hub Australia for funding the research, University of New England and Commonwealth Scientific and Industrial Research Organization for providing scholarship support. I would also like to acknowledge the people who helped to conduct the experiment. For more details, please have a look on the full paper that has been accepted in the journal Frontiers in Veterinary Science. Thank you all.